All right, here we go. We should be live now. Yep. And it looks like we're live. I have no idea if this is working or not. All right. I guess we better get started. We've got a lot of work to do. If anybody's out there, let me know in the chat. Say hi. And that's it. Just letting everybody know right now. What's up, Ben? Good to see you, buddy. Send you a message real quick. Yeah. Can you hear me all right? Is that coming through pretty quick? There's a bit of lag for sure. It's got to be in the seconds. Very good. Let's get into it, man. Happy you're here. You're the only one right now, by the way. I guess that goes to show how popular I am, huh? Neighbors are doing fireworks. So you're going to hear plenty of that. How you been, man? What have you been up to? Where do we start? This thing is going to be a shitload of work. Whatever. Just get started with the basics. Get going on the frame. I don't know if this is going to go well. It's already being very laggy. I'm live streaming and designing on the software all at the same time and running the webcam, so yeah, I don't know if this is really going to work out. We'll keep going, but I have a feeling this is going to get really frustrating really fast. Might as well get you up to speed. What you're looking at is a concept car me and Kevin are working on for this year. This goes back a long ways. 10 years ago, we started the company based off of designing and building our own car from scratch, and that went south, and we had to bail out of that project last year, so we sold everything, and we're starting fresh. So, yeah, starting fresh completely. And that's what this is. I'm trying to work out the details to see what I can come up with. We moved on from the Subaru engine, which was a 4-cylinder, to this engine, which is the LS V8 engine. You can find them in Corvettes, but the one we're going to go with is the type you find in a truck. It's basically the same engine for the most part, but much more cost effective. The Corvette style V8s are higher output and oftentimes lower weight for performance reasons, but they're more expensive and hard to get your hands on. But the truck ones can be built up to the same level of performance, and then the transmission would also come from the truck, and so would the rear axle, and they're very common. So the idea is basically to take a truck apart and rearrange the truck into a high performance race car. And the cost effectiveness of that is really attractive. Parts availability is really attractive. And we didn't get a lot of that with the Subaru. And so, long story short, we canceled the Subaru one, killed it, took it out back and shot it. and then came back in and said, all right, let's do it differently. Like for real, do it differently. In the last project, we got stuck on the bodywork. The bodywork was brutal. We were going to do molds and fiberglass, and it was just going to be an absolute nightmare. And as far as cost effectiveness goes, it was going to cost us a fortune. So it just really didn't work out at all. It was just a straight failure. Took us 10 years to realize that. Anyhow, so this new one here is going to be sheet metal. Sheet metal is easy to work with. It's inexpensive to work with. And it should make the project a lot faster to execute, a lot cheaper to execute, and the whole entire point of this is to get as much widespread adoption as we can. So it really has to check those boxes. It's got to be fast, it's got to be cheap, and it has to be easy to make. And so that's what we're trying to do right now is we're trying to figure out how we're going to check all those boxes, and we're coming at it from a new angle. This new angle, to me, is starting to check all the boxes very nicely. You know, Silverado is a good truck to base everything off of, and that's where the LS engine comes from. But you could do a Ford, you could do a Dodge. Basically, any truck V8 is going to work really well for this. And that's what's going to make it so attractive. You can pick those up for very inexpensively from like a junkyard. But I need to solve a few problems, and we're going to try and do that tonight. I've got let's see, midnight's coming up in about 6 hours. So in the next 6 hours, I'm going to try and figure out how we're going to do the frame inexpensively. I'm also going to try and figure out what else am I going to try and figure out? I mean, the controls, it'd be nice to get to the controls, but for the most part, it's really the frame. How is this all going to connect together, and how does that affect the sheet metal bodywork? Because what you're looking at right now doesn't have any volume. It's just pretend, you know? It's just basically me playing around to figure out what is possible. So, that being said, let's get started. All right, so first things first, I'll probably start in the rear of the car, and I'm going to go, probably going to start from the engine and go forwards. That will probably be the easiest thing to do. I'm procrastinating. Okay, here we go. Fuck it, let's just get started. I don't like that plane, so I'm going to build a fresh plane here. Let's go with, probably do like a offset plane. That's what I want. Yeah, that's our buddy Kyle. He's our neighbor. He's got a train horn on our, he's put a train horn on his truck. You always hear that guy coming down the road. Okay, so now we'll set that plane to the bottom of the car. Ooh. Ooh. It's struggling. Bless this computer's little heart. Let's bring it down. 10. Is that going to be alright? Yeah, it's pretty much perfect. Okay. So now that we've got that plane set up, we need one more plane. No, we don't. I think the stock planes, the planes that are already there, are probably just fine. Okay. And here we go. So what we're going to do is go to this angle here. This is what we want. And I can kind of see, yeah, we want that plane to start with. Very good. We're going to go with the rectangle. Here we go. So we're going to go with probably a 2-inch tube. We'll probably make it 3 inches tall. 2 by 3 would be a pretty stout tube. And then probably go with a 1/8 inch wall. Yeah, let's see if we can reverse that. 1/8 inch wall. And the good news here is that we only have to design half of this, because as soon as we're done designing half of it, then you just use a feature in the software to mirror that to the other side. So it's pretty easy to work with. Okay, here we go. This took a lot longer than I expected. Poor little computer's working its heart out right now. And let's go. Some of the bodywork that I designed here that's kind of guiding what I'm doing is curved, and we're probably not going to do that in real life. In real life, we'll probably straighten out some of the curves just to make it easier to manufacture. Once you once you do a curve, it just adds a layer of complexity and challenge, and it's really undesirable to do that with sheet metal. Sheet metal can handle. All right, hold on a second. Getting a warning here from YouTube. YouTube saying that I'm. Yeah, it's saying that YouTube is not receiving enough video data to maintain streaming smoothness, or as such, the views may. Yeah, views may suffer. Understandable. I mean, how does it look on your guys' end? Is it looking okay? I don't know. This may not be workable as much as I would like it to be. Between the software really bogging down the computer and the live stream really bogging it down, I don't know if I'm going to be able to keep this going. Yeah, we'll have to we'll double up the extrusion on this one. Carry it back as far as I can go until the diffuser starts to interfere with the tube. Oof. Ooh, it's really lagging right now, real bad. Let's see. Okay. Yeah, so the diffuser's kicking in right. Yeah, right about there. That's about as far as we're going to go. We're going to go 19 on that. So what's that total? I got to make sure this is Fine. 111, so just shy of 10 feet, it's like 9 feet. So that's workable. We can do that. Okay. And we'll just push on. As long as we can manage, we'll just keep going. All right, let's keep going. I don't like that. Let's get rid of that. Let's delete that. Let's do. Let's do this. Thanks, Sid. Appreciate you being here. Thank you for saying that. Really appreciate it. Automatic lights keep turning off. Come on. Thank you. It was a lot harder than it needed to be. As a matter of fact, I didn't even need to do that. I have to do a profile on this. It can't just be a straight extrude. It has to be a profile. Uh-oh. Uh-oh, we might have a crash. It's thinking real hard right now. Bless this little laptop's heart. Trying to do 3D design as well as live streaming to YouTube at the same time. And it made it. Who would have thought? Better save it now. Learn my lesson. Learn that lesson the hard way a lot of times. So what we need is, I wonder if that profile will actually work the same. Well, we can only find out if we try. We're going to go with a sweep. Profile. Path. Let's see if it'll let me reuse that path. Hope it does. Fusion 360 is having performance issues. Poor little computer. It's working its little heart out. It will. Right on. Good on you, Fusion. My God. Sometimes stuff just surprises me. Been working with this software for years. Every once in a while you get a little nugget like that. It's a very pleasant surprise. So yeah, I'm just trying to keep this as simple as I can. You know, the whole entire premise of this is not to repeat the mistakes of the past. The first concept car we put together was ridiculously difficult. And if you go back through our YouTube videos about 7 years ago, we were doing castings and everything was very aerodynamic and organic and needed molds, and it was just a nightmare. Ugh, I get chills just thinking about it. It's only 2 people in this project and we had to do it all. Wasn't going to happen. So what we're going to do now is this whole entire concept is all going to be square tubes, except for the stuff that needs to be round tube for racing regulations. They do specify which oh, it's too early for that. They will specify which tubes need to be round. But for most of this vehicle, it's just going to be a bunch of squares, just because, or rectangles, squares, rectangles. But it'll just make life a lot easier for us to build it, but also for other people to build it. And then right over the top, we're just going to put sheet metal, and that's it. Before, we were going to do molds and everything was going to be very aerodynamic, but we're just going to do something that's kind of crude, and even though it's not the most perfect aerodynamic thing, it will get the job done. Okay, so we're going to want to stop that top tube, probably going to want to stop that right at the foot controls. And then we'll have to start going downwards. So let's do that. What we'll do is, what are we going to do here? Could just cut it, do like a Yeah, we'll do a cut. There is a nose line that I'm trying to follow right here, so we'll get in real close. See that little line right there? We're going to start there, and we're just going to go right across something like that. So now we'll do proper cut. There we go. Now we can just get rid of everything that we don't want. Thinks. We just want it to go through the main frame. That's it. Okay. Good. So then that'll cut it like that. That's not what we're going to do in the real world, although we could. There would probably be a tube that goes across and down at the right angle, and that will set the nose angle. So, but for now, I just want to start getting things crudely in place. It's going to take me months to design this thing, probably the next 2 months. So don't expect miracles. I'm not going to whip out a full-blown car ready to go in the next 5 hours between now and midnight. It's not going to happen. But I wish it could. I'd get a lot more done in life if it was like that. Okay, I'll just make sure. I'm doing a lot of double checking. No point in designing. Oh, jeez. No point in designing the tube if it's just going to interfere with all the other stuff. So, what we're going to do is just verify that it's not interfering with the panels in a negative way. Looks like it's following the body shape just fine. It's missing the engine. Now the exhaust is going to have to come out right between the tubes. See the exhaust. Oof, it's really hard to see. The exhaust ports. Yeah, the exhaust ports are. It's not clear. It's a lot of noise there. But basically the exhaust is going to come out between these two and then go into the airstream and then out the back. And that should work just fine. And that would also give it room for turbos down the road. Probably do a twin turbo setup way down the road, like a year or two from now. Okay. So far, I'm happy with that. Let's put in a tube that connects these fronts, and we'll start there. Okay, so we're going to do, let's get rid of the body for now. We're going to do another plane. We're going to plop it right on there. Hmm. Don't really want to do that. Oh no, I could. No, I don't want to do that. Let's not do that. Let's put a plane. And get close. Close enough is good enough. Can adjust it later. Okay. Put that on there first. That should line up. Okay. Now this one is just a straight extrude, which will be real easy. Wow. What are the odds of that? All right, I don't like how this is turning out. Start over. Okay, now this time we're going to design this to be on this surface here. What we're going to do is a particular type of rectangle. I think it's called a 3-point. Yes, 3-point. Or, you know what we could just do? Yeah, let's just do projection. And let's see about That's what we want. So, if what we could probably do is, because I haven't done this in a long, long time, you guys. The last time I did tube modeling was, it was back when we were using SolidWorks. That was probably 5+ years ago. I haven't done it since, so I'm having to relearn all the techniques and tricks. Yeah, I'm gonna create a new plane, and it'll be what it'll be is a 3-point plane. Let's see here, 3-point plane. There, there, there. Okay. Now that plane should be pointing correctly. No, it's not. Let's see, how am I going to do this? Oh, you know what? I should. That's why these two are not at the same angle. They're a different angle, so that's making this cut here at an angle. Damn it! Got me. I have to redo it. Ah, fine, whatever. Okay. Start over. We're going to start over with a cut. I need to make that cut match the bodywork profile. Okay. And this one. Yeah, right there's the bodywork profile. So, what we actually want to do, or what we probably should do, is because that would be a really long cut. What we probably should do is lop off. We should probably just lop it off at an angle so that way the tube can then come down here to meet this other tube. That's what we should do. Alright, let's make it so. Actually, you know what? I don't want to do a sketch. I want to do a projection. Let's go with that right there. And then what we'll do is we'll grab it right at that intersection. Just like that. Okay. Okay. And now we will cut it. This actually stands a chance of working. Come on. What's the matter? Why are you upset? Oh, damn it! 3D sketch. Damn you, 3D sketch. It's still a closed profile. That should have worked. Oh my god, why won't you grab it? What is the matter? Fine, whatever. I'm gonna be like that. Boom, got it. Now we stand a chance here, gentlemen. Now we stand a chance. Right. Okay. So now that we've gotten somewhere with this angle, let's see how it turns out. So we're going to do another sketch. We're going to do it on that plane. Okay. Come on. There you go. Yeah, we're going to have to go more. Got it. So this should be easy now. We'll just roll it back, adjust that angle, and la-di-da. Sketch. Okay. I mean, it's, you know, it's heading in the right direction in my opinion. It's probably too shallow. I wish I could keep that visual. You know what? Stupid. You can't. Just turn the body work on. Idiot. I just had an idea. Oh, I just had an idea. Yeah, I just had an idea. What if I think we need a perpendicularity constraint. So if we go from there to right, what is that? Right there is where the nose connects, right there. So, oh, it's all coming back to me. Oh, it's all coming back to me. It's been years since I've done any of this design work. Where are the constraints? Where are you, constraints? Oh, come on. Come on. Yes, yes. Okay, very good. So now we just got to drag that down. Right. Yeah, so there's a secondary aerodynamic device going right there. So I think that's the one we want to prioritize. So we'll put that there. And now we'll reduce the extruded distance. Something like that. And then set to join. I don't want join. What I want is a new body. Ah, it's all coming back now. God damn. It's been such a long time since I've done this stuff. Holy hell. Okay. Okay, now I've got a recipe to work with here. There. There. Now this thing's gonna cut through a lot of stuff, but just like before, we'll just filter out what we don't want it to cut, and that'll be that. Oh, come on. That's it, I think. Yeah, that's it. So, I know it looks childish and kind of crude, but that is the point. It just needs to be good enough to get the job done. So now we're going to just keep doing this, but we're going to triangulate the rest of the chassis all the way back to the solid rear axle. And once we get to the solid rear axle, we'll have to make some decisions on what we're going to do here because there's mounting involved. And you guys are probably thinking, what are we going to do for the suspension? Well, I got some news for you guys. I don't know. Surprise! But I have an idea. You guys may not like the idea. You let me know. But there's been some examples out there of suspension that was quite crude, and I'm mostly referring to the shifter cart guys, and it worked pretty well. So, what I'm referring to is rubber mounts. This car is only going to be 2, maybe 3 inches off the road, and it's not going to use all that clearance for suspension travel. So we only need about 1 inch of suspension travel, give or take. Probably give more than take. But the point is one of the hard lessons we learned in the previous concept was the amount of money that we were going to put into controlling the tire's motion for a single inch was ridiculous. It was a lot of research and geometry. We spent years on that. And then if you consider all the components, the shocks, and the shocks could be very expensive and have tons of complexity built into them, and you're only going to regulate about that much motion. It just didn't really seem like a good investment. It seemed like the law of diminishing returns was kicking in, and it just pained us to put all that effort in, and we knew there were bigger problems, much bigger problems. And so that's what I'm going into this project with, that mentality is it's just 1 inch of travel, maybe a little bit more than that. What's the stupidest, simplest thing I can do to control that 1 inch of travel? And I think that the answer here is just to do a multi-link connection for the axle, just to prevent it from doing too much rotation, because you don't want to rely on the rubber all by itself. That won't work. The rubber could easily get ripped off when you really apply the throttle or the brakes. So you're going to have to do a multi-link multi-link joints in the rear here to stabilize the rear axle, but as far as controlling how the axle moves when it encounters a bump, I'm not joking, I'm thinking just a thick piece of rubber, and you could manipulate that rubber shape so you get a different profile for how it compresses. You can manipulate the materials that the rubber's made out of to adjust its dampening and its overall springiness. The list just kind of goes on. You could include a dampener if you wanted to, but I'm just proposing that we just do rubber and that's it. And that the whole entire concept here is the simplest and the fastest and the cheapest car we can possibly come up with. And so if we stick with that, these are the kinds of ideas you start throwing around, because if you think about double wishbone suspension all the way around, you're also basically saying that we're going to buy shocks for all four corners, a bunch of Heim joints or other things for every corner, and before you know it, it starts to get really, really expensive really, really quickly. Not recommended. I mean, you got to be really serious. Really serious if you're going to do independent suspension all the way around. You got to be really committed to the performance aspect of it. Okay. 7 o'clock. 5 hours to go, gentlemen. Nobody's here in the chat. Yeah, whatever. So it is, so it be. Hmm. That would be pretty easy. I don't have to design it to be hollow, but I'd be curious to see what the weight is. Yeah, so I'm probably going to stick with hollow because I want to know what the weight is. That's what I could do. Let's try it. Let's just see what happens. I'm going to take a break real quick, you guys. Doing a bathroom break. I'll be right back. Okay, back. Took a little break there. Went to the restroom and then did some fireworks with the family. Oh, thanks, Mark. The mini used rubber donuts. Quote unquote. Springs. I like that. Yeah. Yeah, I'm definitely leaning in that direction just out of simplicity's sake. You know what this chassis is starting to look like? Is starting to look like a dirt track. I don't know if you guys have ever seen the dirt track cars, but they'll have big square tubes and the front end will be slanted a whole bunch just like this, but it'll have a huge bumper slash bash guard on it. All right, let's get back into it. So, gotta get my train of thought back. What was I doing? Right. Okay, I had an idea. Try to make these. Yeah, okay. I'm going to do the diagonal pieces with the 3-point. So it's a 3. Just like that. And then, because I want to use this with the bandsaw, let's see here. Yeah, I'm going to set that to 45. Good. And then project. Trim, get rid of the excess. And go. Okay. And what we'll do is hollow this sucker out now. That should make it pretty easy. Now, there is one. I've forgotten how to do this. Inside, outside, both. No, I don't want to do both. Well, let's see what happens when you do both. Does that hollow it? Let's see what does it do. Nah, it does not hollow it. Damn. Inside it is. So that gets us close, but not quite there. So the easiest way is to go down in here, click that, P for project. Ah, come on, don't do that to me. You're killing me. Okay, there we are. Now we can just cut right through that. Yeah, whatever, it's fine. This will just get us close. It's not going to be perfect because right now, still in the concept phase. So I just need to whip something together quick and dirty. And once we've got something to look at, we can then assess how we think this is going to be, weight wise, how we think it's going to be packaged with all the other components, and then if we think this is good, then we'll commit. But right now we just need an idea of what good could be. This is going to repeat a few times, so I don't want to design that each and every time, which means I'm going to do a construction plane and I'm going to mirror it, and then I'm going to probably mirror it again. Let's see what happens here. Good. Then we're going to go with we're going to go with, that's a create function, not a modify. There you are. Bodies, that's good. Mirror plane, right there. Click OK. I bet you that's probably not going to work 2 times in a row, so probably do one more. Wow, I could try. Let's go with a linear pattern this time, and let's see what we get. Down to 2. Okay. Like I said, it's not beautiful, but get the job done. Personally, I'm more, I don't mind it because it's just getting covered up, so I don't really care. But a lot of people care about how the framework looks, and for sure, if that's you, then you're more than welcome to spend a lot of time manipulating it so it looks good. But in this case, what I'm interested in is basically just a tub that everything drops into. That's as easy as it's going to get. So anything more than that, I think it's just a diminishing return situation. We're putting in a lot of time to get back very little. Okay, so there's the exhaust ports. Unfortunately, they are pointing right. Okay, so yeah, we could probably go right out the top of the tubes. Let's see how much clearance we have. Not a lot. So we'll probably have to come right out and go over the top of the tubes there. I might be able to do something different in this section because I can see the exhaust ports right there. It's a close call for sure. Let's get rid of some of this noise. Give it a minute. It's thinking real hard here. Bless this laptop. It's doing a lot of work. 3D modeling and live streaming right now, so it's working real hard. Right. I mean, it would have to turn almost immediately. Might have to do something different than that. I wouldn't have to. If the tubes were just cut at a slight angle, then they would just come straight out. And we could probably do that. I'm going to leave it. Staring at it long enough. We've got other tubes to make. So let's go back to the main frame, get that reactivated, and let's keep going here. That looks good. Go lay down. Go lay down. Go lay down. Okay. It's convenient. And thank you. So I'm getting getting to the point where I'm probably going to mirror this now. And I think you guys can see what I've got envisioned for this. It's basically just a gigantic tub, and everything just drops into it. And then we're going to cover it up with body work. That way, you're not really going to see it. So it looks really simple and childish, and yeah, it's basically the whole point. So I want this to be the easiest race car in the whole wide world to build. But also, once you cover it up with some sheet metal bodywork, it'll look pretty good. The idea there is that more people will adopt it, and hopefully down the road we can turn this into like its own league, and we can regulate it in a way where there's like a cost cap, and that cost cap will help make sure that it remains a budget, high performance race car. Let's see here. This line, we're going to extend that line a little bit further. You guys can't see it right now, but I got two dogs in the shop that are absolutely terrified because the neighbors are setting off fireworks, and they've both found a way to get underneath the desk. And there's a little space heater under there because it's cold here in the shop. And so one of them is laying directly in front of the space heater, and now none of the heat's going over my cold feet. So we'll see how long that lasts. Okay, one more diagonal piece, and it's time to start doing straight pieces. So we're getting close here, really close. We've got a lot of other things to work on. For example, I'm sure a lot of you are probably wondering what we're going to do for the front suspension. I got a little surprise for you guys. I don't know if you're going to like the surprise, but I've got one. And we're going to see what everybody thinks about it. But we'll tackle that bridge when we get there. Let's finish this up. Very good. I think that covers it pretty well. And there you go. So then what we'll have to do now is down the road we'll come up with some multi-link bars to connect from the main frame to the axle to stabilize it, and then we'll just put some rubber bushings in there to provide all the spring that we want, and that's pretty much it. Okay. So So that's pretty much what I want to do. Now, straight pieces. Let's just go ahead and mirror it. Let's make that leap right now. Might as well. We're going to select all of these, and we're going to do it across the mid plane right there. Come on, grab it. Okay. Don't hesitate to ask any questions, guys. I am keeping an eye on the chat. God, that's so simple. I mean, you could probably fabricate that whole thing in a day. I'm not committed to this tubing here. I'm very, very much so in a kind of wandering sort of thinking about what could be. So don't freak out. Don't freak out. Just keep in mind that Matt's just wandering the space of framework and bodywork right now, which I will turn that bodywork on. Let's see how things are fitting or possibly not fitting. Let's go back to, yeah, we're going to go back to come on, little laptop, you can do it. You're a champ. I have faith in you. Save it before we lose our progress. Yeah, so you can see some of the bodywork's poking through. Now that's fine. There's negotiation on the bodywork. It wasn't exact, but you know, I want things to be within maybe a half an inch or an inch of where it would be in the real world. So it needs to be at least representative of what we would actually do, because I'm trying to gather. What am I trying to say here? I'm trying to get situated, trying to get my head in the right space. What could be done with just some sheet metal and some square tube framework? Like, what could you conceivably do? And so far, this is what we've got. So I like it. I like it a lot. Oh, come on, software. You can handle it. Come on. There you go. Okay. So far, I'm liking it a lot. I think you guys see it now, don't you? Some square tubes, rectangles. Really crude, really simple, but still effective and safe. And then right over the top of it, you just put sheet metal panels. That's it. And you call it a day. The windshield will need a little bit of work. It's going to require a subframe, and it also needs to swing out of the way so the driver can get in and out. But that's just going to be laser cut or routed Lexan, and then that's going to attach to the subframe. So there's some details there to flush out, but yeah, there's some interference. There's going to be these sheet metal panels are going to have to be adjusted for sure. Are we going to outsource that to laser cutter or plasma? Probably not. What I have in mind for us is, I kind of like that look where the frame sticks through like halfway and then it's filled in with sheet metal. No, Matt. Chill out, dude. Don't make that shit more complicated than it needs to be. Just cover it up. Just cover it up. That's what we want. Yeah, we'll just cover it up. That's every time I start a project that happens. It always gets more complicated than it needs to be. Just don't let it scope creep. We need to downsize the scope is what we need to do. Whenever you guys get into trouble like I do, and you know what I'm talking about when it comes to projects, you get yourself into a lot of trouble by taking on more than you can handle. Just start cutting. Just when I start cutting, man, life gets a lot better. If you can't handle it, get rid of it. If it doesn't need to be there, then you won't miss it when it's gone. Okay. I'm fairly content with that. You know what we need? We need a fuel tank. I wish we could just download a fuel tank. Let me check the internet real quick, gentlemen. You're not going to see this because it's a completely different screen, but I'm going to see if there is a fuel tank 3D model out there. See if we can grab one off of GrabCAD or something. I don't know what's a good size for the fuel tank. See what you guys have to think about it. I'm trying to think who's a good potential source for fuel tank. Well, you know what? Oftentimes Summit will just list the dimensions, and then I could just whip together a 3D model real quick. I'm thinking we're going to need to go with 10 gallons if I want to, a basic sprint race. A sprint race could be anywhere from 5 to 10 laps, and the lap times could be anywhere from 2 to 3 minutes, depending on which track you're talking about. So that's 10 to 15-minute track time plus a little bit of margin. So I don't know what the fuel consumption rate is at 500 horsepower for 15 straight minutes, but I'm just going to guess that it's probably 10 gallons. Let's see here. I'm probably going to want something that's the shape of a triangle and tuck it in behind the seat. That'll help centralize the weight distribution. We could definitely put one that's also triangular behind the rear axle here. It's a good option too, and I kind of like that. Personally, I don't like the idea of the gas tank being right next to you. Yeah, sure, there's going to be a firewall. It'll be contained, but still, I mean, the rear just gets hit so often, though, and that's probably why most racing regulations don't let you do that unless it's like, I mean, they will. I mean, you could. There's a lot of people who will put the tank like in the trunk of the car. That's a really common mod. Same goes for the C10 guys who will go racing with the C10. They'll put the fuel tank just in the back of the truck, and that's fine. So maybe we could do that. It's hard to say. The rules are very open when it comes to Global Time Attack Unlimited class. That's what this car is going to be for, because they're one of the very few who would take this car because it's such an oddball thing. So they're one of the very few who would take something like this and let it on the track. And they don't actually say. They don't say where we have to put the fuel tank, so we probably could put it in the back here, although that is shifting a lot of weight towards the rear. If it's 10 gallons at 5 pounds or 6 pounds, I forget what it is. Oh, come on. Let's go with... We don't want fuel tank. We want fuel cell. Whoops. That's why I wasn't getting anything in the search results. Stupid. Let's see here. let's see here. 12 gallons. I would really like something to be more like a triangle and really tuck it in behind the seat. Let's see if they give us a shape. Come on, give me a shape. No, it's not going to. Oh, come on. Five gallons. Could do split tank, 2 5 gallons, one behind the seat, and then one behind the solid rear axle. That's not a bad option. I kind of like that idea. But for sure, the preferred ones have this drop-in style tank, not an inline tank. Or that's probably not the drop-in, is it? No, it's probably not. That's probably just a fuel cap. Damn it. I really like the drop-in fuel pumps because, man, those things are cheap. I mean, well, the racing inline ones are also kind of, they're right there as far as affordability goes. It's just I have this idea in the back of my mind that we're going to be able to just get online and buy a Chevy Silverado and then just strip all the parts off of it that we want. And that's where all this stuff is going to come from: the engine, the trans, the solid rear axle, fuel pump, electric, all that stuff. The only stuff that we're really not going to be able to keep is going to be like the radiator. Okay, this is going to take forever. We need to narrow this down. Let's go with 5 gallons, because I'm not going to be looking at a 22-gallon tank or a 20-gallon tank. Those things are gigantic. Okay, let's just start with the 5s. Let's see how far the 5s get us. Like I said, I'm looking for a triangle tank, something that I can tuck in behind the seat. See what you guys have to say. Nothing yet. Come on, triangle tank. It's not exactly a triangle. I think you guys know what I'm talking about. It's not a perfect triangle. What it is it's more like it's kind of like a trapezoid, I guess is what you would probably call it. Now, we could definitely build one. That's totally within the regs. It's just so many people are going to feel comfortable not building that's the direction I want to go. Is I want to make sure that a lot of things are, for a lot of people out there, they're going to be happy to just be like, okay, yeah, I'm just buying that. I'm not gonna build that because it can be very intimidating. 5, 8, 10. Now I know they exist because I've seen them. I have seen them. I think they actually have a specific name. I think they are called like seat tanks or behind the seat tanks. So I know they're out there. Years ago, bought one, and that's exactly what we did. We just tucked it right in behind. There it is. 8 gallons. I like that. 8 gallons. $500. Okay, whatever. I mean, it's all there. So I would imagine it also probably comes with. There you go. There's the dimensions we need. So let me model this sucker up real quick and then try and shove it in there behind the seat and let's see how we do. Hey Mark, yeah, I just found one. I'm going to model it up real quick and pull it in. Okay. I hope we'll be able to squeeze it in right between the seat and the engine because, man, that would just make me giggle. If we can get it in there, I'm telling you guys, 8 gallons in there, 8 gallons is going to be good. If you go over 500 horsepower, I'll after we're done here messing around with this, then we'll get online. We'll see if there's some fuel consumption rates that we can pull up, or maybe some calculations we can do. Or if Mark, if you're still watching, it'd be really nice to know what our fuel consumption rate is going to be at 500 horsepower, because then we would know for a 15-minute race how many gallons we're going to need. I'm sure your math is a lot better than mine. Wedge. Good job, Mark. It's a wedge. Wedge fuel tank. And the specs are 17, 14, 10. So they say 17 length, but I'm pretty sure that's actually width. But I'm going to kind of guesstimate here because it's not exactly a triangle. And because it's not exactly a triangle, if I just drew a triangle, it wouldn't look quite right. So I'm gonna have to kind of guesstimate here. Okay, here we go. Fuel tank. We're gonna do a diagonal. We're gonna do a flat. Another flat. Come on, snap. And then grab that right there. Okay, and we're going to throw these dims in. Okay, so it's saying 14. I'm going to just guess that's this one right here. I did not do that on purpose, ladies and gentlemen. Getting that on the first try, that was not on purpose. Oops. And we keep going. It is 10 1/4 tall, which probably includes some of the things that are on the top, but we're just going to go with that. And now the depth is going to be 17. So to make this really easy to position, we're going to do a symmetric press pull. And that symmetric press pull will mean that it stays exactly on the center of the car. And then 17 divided by 2. 17 divided by 2. Yeah, what is that? I forget what that is. Whatever, doesn't matter. And now we, you know what? Let's actually, yeah, let's clean this up a little bit because it just kind of bothers me. The real one has a lot of rounding to it. My OCD is getting the better of me. It'll be real quick, guys. Just chill out. Real quick and we'll be done here. Okay. That satisfied my OCD. Now I feel better. Okay. Now we move it. Let's go to move. Oh, dang it. I hate that. Sometimes the lag does that. Just really messes with the click performance. Okay, good. Got it. Come on. Oh, wow. Wow. Ladies and gentlemen. Like, what more? What more do you want? 8 gallons. Let's check the width. Let's check the width. Come on now. Ooh. What more do you want? You guys looking at that? Who's still here? Mark's still here? Look at how beautiful that thing fits. Oh, it's almost like they made that for us, you know? It's like this project wants to happen. It's gonna happen. I didn't even put that all the way on the ground, which you totally could. If you just put a couple of beams straight across so that there is a little bit of a gap there, you could drop that fuel tank all the way down to the floor. It's a little risky, I guess, but if you put a nice thick piece of aluminum in between there, like some 1/8 inch aluminum, Or maybe you could do like 2 layers. You could do the floor pan could be aluminum, and then we could do a steel pan right there in the inside of the tubing. And we're just going to have to do a firewall anyway, so there'd be a whole bunch of steel to encapsulate all this, as well as the engine, because I would also like to have some fluid capture potential for this frame and bodywork. I'm going to promote used engines. I'm going to promote used engines and transmissions from get a lottery ticket. Yeah. It's rare that we're this lucky. I mean, I think you would agree it's probably a little long overdue, wouldn't you say, Mark? For sure. If we won the lottery, it would pay for this probably 10 or 100 times over. We could start our own racing league and just build these things for free for people. That's how much money is in the lottery right now. There we go. Okay. Let's put some straight pieces in now. I feel like I mean, surprisingly, there isn't a whole lot of attachment points, especially because these foot pedals that I went with are actually the over-style footprints. Foot controls. So we could swap those out for the floorboard style, which would probably be better now that I'm thinking about it, because we're going to want the controls to be adjustable for various height people. You really don't want the seat to move. Making the seat move adds quite a few layers of height for framework and for the slide mechanism. It also adds a weak connection point for the seat. You really want the seat to be a rigid mount. We do have solutions for making the steering wheel adjust in and out a little bit, or up and down. That's not too challenging. But at the same time, these are going to be very personal vehicles. It's going to be very personal for us, myself and Kevin. So it doesn't need to have infinite adjustability. It just needs enough to satisfy the people that you think are going to drive it. And being that this is going to be based off of the automatic transmission, the user friendliness is going to be fantastic. If you can push a gas pedal and a brake pedal, you can drive it. Maybe that's not a good thing. But the point is that I'm thinking that maybe the pedals would be better off on the floor, but we don't have to solve that problem right now. Right now we're just kind of eyeballing it just to see what is possible. Get a gauge for what could be done. And we can answer the should be's later. But right now I want to know what can be done. Same thing, because this is a fully symmetric framework, all I have to do is design up the bottom connections, and once the bottom connections are designed up, all I have to do is just pretty much copy those up to the top. We're going to want one going across to support the steering, and we're going to want one to go across to support the foot pedals. We're going to have some going across the floor for mostly the floor pan. The engine doesn't really attach directly to the floor. There's an attachment point somewhere in the middle there. Lots of stuff online about 500 brake horsepower. Boat fuel consumption 2.5 miles per gallon. Nothing yet on race cars. Thanks, Mark. Really appreciate that. I mean, if that's accurate, you can your typical track is going to be 10 plus miles, so 2.5 miles per gallon. Take a few gallons to go around one lap. That's probably not right. 2.5 miles per gallon. Oh, okay, maybe. 500 horsepower is just a good round ballpark number. Just because 350 horsepower is where most of these stock engines start off at, unless you go with like the smaller ones. Smaller ones are less than that, like 310, 325. But as far as the engines I would personally pursue, I would pursue the 6.0 engines. Iron block or aluminum block doesn't matter. And those you could very easily get to 500 horsepower with a few bolt-on mods. And so I'm thinking maybe we should just design it around enough fuel for 500 horsepower. But I mean, there's 8 gallons already, right? So what we could do is put another one in there. Probably not over the top of that fuel tank. I really like how that fuel tank fits, but in the back here, we could do another one in the back, and then we could just connect them together with a line, so that way it drains. So that way the back one drains into the front one. The front one retains the pump. And the way that we would do the recirculation of the fuel is we could probably do the return line. So the return line would go to the tank in the back, and then the tank in the back would have a drain line going to the front tank. And I bet you the tank in the back would actually be slightly higher up. Because we're going to put a diffuser in the back here. Not a very extreme one, but a very basic one in the back. And if we do that, then that's going to push the tank in the back here up higher a little bit. Then you could easily get over 8 gallons. We could probably go up to, probably add another 5 in there. So that gets you up to 13 gallons. I'm going to get some water. I'll be right back. Three hours and 30 minutes to go. Okay, we're settled in. The dogs were restless and they're underneath the desk. Okay. Straight pieces. Let's get them in. How do I want to do this? I'll do it from we had so many problems with this in the past. We actually built a mock-up out of wood back when we were doing this because getting in and out is such a pain. When you do a reclined seat like this, it really sucks to get in and out. Cup Series NASCAR is 2 to 5 miles per gallon racing, 14 to 18 miles under caution. Yeah, I don't know if this 8 gallons is going to last very long. That's a good start. I believe those cars are 1,000 horsepower. Don't quote me on that, but for sure, I think the boat data would probably be a little bit pessimistic because boats I know are less efficient. I believe. I don't know, maybe not, but I believe the NASCAR guys are 1,000 horsepower, which means that at 500 horsepower, maybe we'd be able to do better than that by a factor of almost 2 to 5 miles per gallon. So maybe we could do like 4 to 10 miles per gallon. So, yeah. So if you assumed a gallon per lap at a typical track, and that would be like a 5-mile course, 5 to 10 mile course. Let's assume double what we can get. So let's say it's somewhere around 10 miles per lap. which I don't know if that's accurate or not, but let's just assume it is, then a 5-lap race would be 5 gallons. So that's significant. That's not a joke. 8 gallons would get eaten up real fast under those conditions. We can worry about that later. Because like I said, we can double, not necessarily double, but we can increase the fuel capacity a lot by just putting a tank behind the solid rear axle. I'm going to keep going with the framework, and we can revisit that problem in the next couple of hours. Because I'm going to be up until midnight, so I'm going to be doing this for, see gentlemen, we've got 3.5 more hours. See how much more progress we can make in 3.5 hours. Okay, mainframe. Thanks, Mark. Yeah, 750 to 800. Okay, that sounds a lot better than 1,000 horsepower. So if that's the case, probably not going to be able to get double that then. So 8 gallons is probably not going to get us very far, I wouldn't imagine. But it does fit really nicely. For sure, we could do a heck of a lot better with a custom build. It's just I'm just concerned about that. I really like the idea of people being able to just buy it and drop it in. So for now, I'm thinking we'll just leave the 8 gallon in there. I didn't see any others bigger than that were also this shape. If they were bigger, they were just big rectangles or squares. Yeah. I found a smaller one. There's smaller tanks. That could probably go in the rear. But I bet you we could double it. We could probably put that exact same tank in the rear, and that we could get you 16 gallons. Which the Le Mans cars, I believe, they're 20 gallons. The LMP cars. I believe if we look up the stats on them, I think we would find they're about 20 gallons. I forget what horsepower they're doing, but they're doing pretty high horsepower too. I think they're around that same range, 750, 800 horsepower. Don't quote me on that, but if that's the case, then probably the LMP car data would be more representative of what we would need to do, because that's kind of where we're going. Those cars are larger displacement V8s, just like the NASCARs, but the aerodynamics are different. So I wonder if that data would probably be more appropriate. I'm thinking it would be, but okay. Let me put in a few straight pieces here, and then let's come back to the fuel tank problem. So this is going to be pretty easy here. These straight pieces should just go right in. I am going to change the orientation just ever so slightly. Instead of being vertical on these other tubes here, I'm going to go horizontal with them. You'll see here what I mean in a second. Okay. So for sure we're going to do one tube right at this joint right here. And those are parallel, which is good. Now, before we had the long dimension, vertical, but now I'm going to change it to horizontal. Okay, and that'll buy us some more interior. That'll buy us some more interior space. Let's go with that there. Oh shoot, I set that one to join. Not that it matters, but if we wanted to use this for a gauge for like a cut list or something like that, you don't want them to be joined because then the 3D model will treat them all as just one big chunk. We don't want that. We want them to be treated as individual pieces like they would be for a weldment, and then we could create a print for each. So I'm going to be my OCD still kicking in. Ugh. It even bothers me that this shell does not work completely. The other side here isn't open. It doesn't make a tube. It makes it like a box. Oh, it's too early for that. Ugh. I got 3.5 hours to go. It's way too early for that. There's definitely going to be a whole lot smaller tubes going every which way. It's not going to be just these big tubes. So keep that in mind when you're looking at this. There's going to be a ton of small tubes going every which way. So there's that one. And then we probably want one just going right behind the head. Well, that will probably end up being round because that's where the seat straps are going to go, and that's going to have to be round. So there'll probably be a round one going through there. So we'll leave that one alone. Let's see what else is going to be on top here. Most of the top is not going to be welded because I want every component to just drop in literally like this is just a big tub. So I imagine all of these top components are probably going to be bolt-in components, which is fine. Doesn't really matter a whole lot. So for sure the back here is just basically just needs to be capped. That's all that it really needs, is just to be capped. So probably the easiest thing to do would actually be to probably model it on the side. That's what I'm going to do. I'm just going to do it on the side. We're going to do it right off the mid plane. Thank you. Thank you. Okay, grab that one right there. We're going to go snap. Let's see. Non-hybrid Elamine car only has a 20-gallon tank. Surprisingly small. I agree. So 8 gallons sounds like a good choice. Okay, we'll stick with it then. 8 gallons for now, and till further notice. Let's just put it that way. There's a lot of other question marks left to answer. Yeah, the lag's getting real bad. Sorry, gentlemen. It's getting real bad. It is what it is. So you know what else is coming up, which is a big question mark, is the radiators. I'm not going to do a big radiator. I'm going to do a split radiator. It's not that technically challenging, but for sure, I would like to pick one off the internet that's going to do roughly half of the cooling capacity. That will need to be kind of guesstimated. So, like what's what single radiator is typically used for 500 horsepower, and then try to find one that splits in two and get those dimensions, and then I could plop that in the 3D model here and see how the bodywork fits around that. So that is a pending problem that's on its way. I'm trying to think what other problems are on the way. Brakes, that's another problem that's on the way. Spindles and brakes, they all kind of go together, because whatever brakes and spindles you want to run is related to the wheels you want to run. And what I've selected so far for the wheels, just for mock-up, so don't jump the gun on me, but just for mock-up, it's 11 inches wide. It's like I want to say it's 300 millimeters wide, and 20, or I think it's a 19-inch rim. So then the tire, I believe, is a 23 or 24. So it's got an okay sidewall, because we want the sidewall to also be in our favor at least a little bit. Because like I said, if we do a very minimal suspension like rubber bumpers, then you'll probably also want to make sure that you're not running a very low profile sidewall. Because if you do a very low profile sidewall, one, if you do hit like a curb, specifically like a rumble strip, maybe you'll pinch the tire. I don't know, I'm just kind of speculating. So I'm leaning towards a thicker sidewall. So not doing 20 or 21 or 22 inch rims, which a lot of people like to do for aesthetics. There is a very small argument to be made that the lower sidewall means the tire is more rigid. I think it's a small argument. I don't think that's a very strong argument, but maybe it is. But in my opinion, I would personally favor on a thicker sidewall. If we err on a thicker sidewall, you could always swap that out down the road. You're not committed to it. But for sure, if you go with a thin sidewall, a low pro, and you do curb it, and it does damage things, you're going to be really upset. So for starters, I would go with a thicker sidewall, just because of that alone. Now, some of this stuff is highly, highly suspicious. I highly doubt that the solid rear axle is going to be able to get this close to the transmission, because there's going to be a yoke in here, possibly two yokes. I'm not exactly sure yet. It just depends on how much motion we're trying to get out of the rubber pucks, but an inch or so here or there, and it's going to get cut down. It's not, the pumpkin here is on the inside of that articulation, and because it's on the inside of that articulation, it should get reduced. So the wheel's going to move an inch, but all the way in here at the pumpkin, unless both wheels smack into something at the exact same time, the pumpkin's probably not going to move a whole inch. I think it'll get cut in half. Maybe, I don't know. I've been wrong so many times. Just remember, I speak with great confidence, knowing full well and good I am completely clueless. I just like to sound like I know what I'm saying. Okay. Now, another thing that's going to be kind of interesting is if we do go with some high downforce surfaces, like a really big rear wing, that's really going to mess around with the rubber. That's really going to mess around with the rubber choice, because basically you're going to want to set the rubber up probably for the amount of load you think the car is going to see, which if you're at a really fast track, you're going to have some really high aerodynamic loads, but if you ever slow down, the thing's going to be like solid as a rock. Tiny little cracks in the road will make the car jump up a whole bunch, bounce around all over the track. It's going to make a great YouTube video, I'm telling you. I think that's where my mind's at these days is, it used to be like performance, but now it's like, what can we do that's just going to be entertaining? And I think this will be good fun. And it's not going to be anywhere near as expensive as the previous projects we had conceived of. Oh, God. Okay, just a couple more tubes just to round off the back end here. And what we'll do here is, since I'm modeling these to be reasonably accurate, we'll get a weight on it. And once we've got a weight on it, we can do some guesstimations on the overall vehicle weight. Cross your fingers. If it's under 2,000 pounds, I was just doing some paper for funsies math, and the cross-sectional area of this car, and I'll show you that in a little bit if you're interested, is about half that of the Ford Mustang. So the cross-sectional area is dramatically reduced, which I'm very happy about. And with that change in cross-sectional area, we're getting some really good performance gains as far as how efficiently that horsepower gets translated into acceleration and into top speed. Or you can trade it, because we don't have all that drag anymore. We could trade it for top speed or downforce, depending on what the track conditions are, which has got me very interested. Specifically the downforce option. So if we trade that drag for downforce, because we're going to have gearing limitations, you're not going to be able to go. We're not going to be able to set like land speed records, but some of the ratios that we could probably get for this thing will get us up into the 200s. Which would be spectacular. But the really, really exciting stuff happens with the downforce, because then you're talking about your braking and your cornering just being mind-numbingly sudden. That's exciting to me. I mean, top speed's definitely exciting too, but Google says a good rule of thumb for the rad size is 1 square inch per brake horsepower. So 500 horsepower should be 22 by 22, or 2 rads, and then it's 11 by 22. How much space do you have? Oh, for the radiator? Let's see. Well, quite a lot. There's a lot of opportunity space. Let's put it that way. So if we turn the body back on, I've got some pods on the side here. Yeah, those have a 14 inches. Oops. 14 by 15. by 15 for each side pod. So double that for double only one dimension. So the 14 28 by 28 by 15. That's the total size, is 28 by 15. So what they're saying is a 22 by 22. If that's the case, then we're good to go. If we could find a radiator that roughly slots right in, yeah, 420 square inches. Yeah. So if we found one that would slot right into that roughly 14 by 15 square area, which I think like Honda Civic stuff is probably about that. You know, the smaller 2-liter engines are about that. So if we got a multi-core radiator for a Honda Civic, like a high horsepower Honda Civic, there's a good chance that radiator would slot right into the side pods. And then there you go, just get 2 of those. That would be very budget friendly, and it'd probably give you a lot of cooling margin too, I bet you. See what Summit has to say about Honda radiators. See how big they are. Cause let's see, Honda Civic. Cause that's what I'm thinking, is if we picked a radiator, a high performance radiator for a 2-liter engine. Yeah, I agree. And then that sucker would just, yeah, I agree. Because if that is a good option for cooling capacity, it's not going to get much better than that. It's going to be cheap. It's going to be readily available. Let's see here. Okay, so I already found one. Mishimoto Performance Radiators. Let's see how big they are. Ha! 14.6 by 18.5. There you go. There you go. The core, yeah, they've got a core here. The core is 13.78 by 14.9. The thickness is 1.6. There you go. That's it. Let's see if I can share that link in the comment section. That's our winter chicken dinner right there. Yeah, 2 tickets. Woohoo! Go get some lottery tickets. We're on a roll here. Okay, so we're knocking these problems down. This is one of those projects that's like teasing me, you know? It wants to be built. I told Kevin, I said, you know, a lot of this stuff is going to be truck related stuff. And I half-heartedly tossed out the idea of us just getting a Silverado off the internet, and that's why you see the project file name is actually the Silverado. I was kind of playing around with that. I don't really like it. But pretty much everything we would need would come off of that truck. Spindles, rear axle, the brakes, the foot controls, we could recycle all that stuff. The computer and harness, we could recycle all that stuff. If we wanted to do endurance racing with this car, we would want lights, and so we could then recycle all of the light controls from the Silverado. There's a lot there that I pitched to Kevin that, you know, we could build this car like literally off of a truck. The Fords got me really interested because they've got, I forget how many years ago they started, but they started with the twin turbo like the one you've got. And man, would that'd be such a cool build. And I think your transmission actually has the high performance dual clutch. Don't quote me on that. We could look that up. but I think the clutches on your transmission are wicked fast. I mean, it would just pop through the gears so quick. Um, and yeah, those trucks sold like pancakes. Like they are everywhere. We could probably find um, a good donor and then just pull all of the functioning components we want and just rearrange it. So he's not too excited because he's like, well, we're going to end up with a body and a frame. And then what are we going to do with it? Which is a good argument. That's why he earns his wages. Like he's a smart cookie. It's like I don't know. Like, what do you do with a body and a frame that you don't want anymore? I mean, maybe the scrapyard would take it. I don't know. From a Ram truck. Heck yeah. There you go. Use the Dodge stuff. Absolutely. I think the Dodge has some pretty big engines too. Don't quote me on it. Because there's no replacement for displacement. There just isn't. What's that engine you got? How big is that thing? .7 Hemi. Yeah, that's a big engine. That's yeah, you're right there, right behind the 6.0. Yeah, that would be a wild build to put the Dodge stuff in here too. I hear great things about all those truck components. A lot of reliability there, lots of miles. Um, my uncles always have Dodge, and they've loved them for decades. Same goes for like Nissan and Toyota. The Nissan is the Titan, and then the Toyota is the Tundra. But man, if we built this thing off of truck-based platforms, the creativity space would be very large, and that excites me a lot because then you could imagine people showing up with all different kinds of donor builds. Like somebody would do a Nissan or a Toyota donor build. Oh, it's not another truck. Oh, okay. 3-speed auto. Okay. It's probably a strong transmission, I would imagine, right? Okay. A little sidetracked here. Let's see here. 2 hours, 9, 10, 11, down to 3 hours. 3 hours to go for New Year's. I'm gonna try and stay up and work on this all the way till New Year's, and then I'm going to bed. And then I got to get up early because I need to get on a good routine to exercise and get my diet under control. New Year's resolution. Okay. Let's fix. Let's fix this. It's not symmetrical. It's bothering me. Where does the air exit the radiator? It's right out the back here. The back is just completely open. Same goes for the engine bay just in general. The whole entire back end is just completely open. That's going to open with the radiators do their job. Yeah, yeah. Especially because we're going to get that strong negative air pocket back there, so you're going to get a lot of pull from that. So the radiators will probably have their fans, the stock fans on there anyways, but still, it's a nice safety backup, so that way if the fans fail, you're going to get a lot of airflow. Let's see here if you can see it, but you can see from the top view, the air goes between the front wheels. There's an open cavity there that brings the air right into the inlet, and then from the inlet you're going to have a couple of outlets. It's going to go just straight through all the way out to the back. But also I'm thinking of possibly doing some shark fins or gills, kind of like the front has them, and those are the front's using that ventilation for brake heat and tire heat, but the rear we could do the same thing as well. So we also could do some side shark fin vents as well. But I'll have to check the area of the exit, but I'm pretty confident the rear's exit area is significantly larger than the inlet. So I don't think we're going to have any choking issues, and with that negative air pressure back there, it should just suck the air right out. Okay, so we've balanced out that rear frame member there, so probably the only other top member I would do would probably be something like so. I mean, the top doesn't really need a whole lot because we're not doing the A-arms, so there isn't going to be a whole lot of load transfer up to that top tube. So for now, I'm just going to leave it open like a tub, and that way, because what I'm going to do is I'm going to leave as many questions unanswered as possible in the 3D model. That way, there's that on-the-fly creativity is left alone. So when me and Kevin are not going to exactly model every bracket, every bolt and nut, or even the tubes. We're going to model the tubes that matter a lot, and then the tubes that don't matter a whole lot, we're just not going to model them. And then when we get to the build, we'll use some old school techniques like using templates and mock-ups and paper to simulate not paper, but like cardboard to simulate the body panels. And that way we can take a step back and in the real world see what's fitting and what's not. There's no greater mistake than the mistake I made in the past where the 3D model was treated like a piece of art, and then you go and do it and the stuff didn't even fit anyways, and then you're like, God, come on, getting all OCD over the 3D model, and then it didn't even end up working. Some stupid mundane detail was overlooked. So won't be doing that. This is definitely going to be one of those things where the 3D model is just kind of like a rough guide, so we all have a vision of what we're going to do next. But beyond that, it's not really going to answer any real significant questions. Most of the questions or problems we're going to solve are just going to be on the fly. Okay, let's put some bottom tubes in there. Now the front end, I've been looking online for. There are some examples of hot rod or rat rod, actually solid front axles that are already out there and problem solved. I'm somewhat curious about getting one, but at the same time, like, they're so simple, we could definitely make it. So probably, I'm just thinking here for the bottom. Probably there's going to be a transmission mount. I'm suspicious that the transmission mount is actually just going to be something that's like a plate. And the plate's just going to go across there. So that might not even be a tube. So probably want a tube to go fore and aft of the tank, and then probably right behind the bell housing. Get rid of the body for now. Right behind the bell housing. And then up front here, we'll probably do one same where this one is, and then probably one all at the very front. That's probably it for the straight members, and then the rest will probably be diagonal members. So probably like X-brace this stuff out. Maybe, I don't know. We don't have to X-brace it out. I'm just saying we could. It would be better in some circumstances not to, because if you want that seat to be really, really low, you don't want tubing going across under there. which is what we did on Kevin's Sandrail. We made it so that way the seat just drops all the way down to the sheet metal. And it gets you really low. We really liked how that turned out. Okay, I'm going to commit to that. Still on the main frame. So I'm going to drop this tube in on the front here real quick. 2 tubes fore and aft of the tank, and then 1 tube right behind the bell housing. And that's it for the straight across members. Then we'll get a weight on it. And once we got a weight on it, then we can kind of decide what to do next. Probably mock up the front. Yeah, probably mock up the front is what I'm thinking. All right. Easy. Easy breezy. And I have not confirmed that this tubing is actually the tubing that we would use or is available. I'm just going to spitball in here. Let's see. Don't want that. I keep forgetting that. Let's see, with little to no suspension, you could keep the chassis non-rigid and tune its stiffness, make the bolt-in cross braces. Yeah, just like the carts do. Absolutely, absolutely. Those shifter cart guys are no joke. They found some very simple and very effective ways to tune those carts, and that's the only way you're gonna win. Is if you don't tune the cart at all, like, you don't stand a chance, because the guys that are out there really pushing hard to win, they fiddle with every little thing they can, and that's the inspiration behind it, is to make a full-size race car as simple as a cart. No joke, some of those cart guys will give a full-size car a run for its money if you're on a really small, tight track. Okay. The computer's struggling a little bit. Come on. There you go. There you go. Whew. Really testing my patience here, man. Whew. This is the computer's running super hard right now to run the software and to do the live stream. Bless its heart. Okay, we're gonna do one. Yeah, we'll do one right here. I really don't like that auto shift. It's annoying. That seat is probably also not representative of reality. I mean, I've checked it so that way it's roughly the right volume, but it's not like it's a model of a Kirky seat or something like that. It's just a generic seat that I found online that'll get us close. For sure, the seat's going to have to be purchased. All of the safety regulations say that the seat has to have a particular certification. I forget what it is. And yeah, I would not fabricate that up. I just wouldn't do it. Especially the Kirky seats. The Kirky seats are very affordable. They're just sheet metal aluminum, so why not just buy that? I'm still in the back of my mind right now while we're doing all this stuff. I'm still thinking, how are we going to make this adjustable so that way different different height people can drive it, because I've got some lines here mocked up for Happy New Year, Mark. Thank you very much for hanging out. I will see you. See you when I see you. Yeah, still in the back of my mind, I'm thinking, how are we going to make the seat and the foot controls and steering adjustable enough for letting different height people drive it? Because I do have lines here mocked up for how the visibility turns out based off of how tall you are. And if you're shorter, your head is going to drop deeper and deeper down into the framework. Your visibility very quickly goes to pretty much nothing. So if you're like a 5, I think the minimum is like a 5'6" person, you are not going to be able to see a damn thing. So that's a problem. Yeah, you can see right there that if your eyesight is exactly aligned with the center of the headrest, you're pretty much looking right over the steering wheel, which we could drop that by using a steering adjustment. And then you can see that there's an angle here. This angle matches the nose angle of the bodywork. So, yeah, that's like, I think 5'6" for the height of the person is the limit. Otherwise, you're not even going to be able to see out the front of the car. Who designed this thing? Well, you're talking to them. You guys are complicit at this point. Like you watched it happen. You didn't say anything, so you're now accountable for it too. We're in this together. Teamwork makes the dream work. All right. Okay, 2 more. We're gonna do 1 fore and aft of the tank. Let's see, still in the mainframe. Yes. And there everybody goes. There's nobody left. That's fine. It's just... Let's see what we got going on here. There. And we'll do another one. Right there. Okay, back to work. Let's see, 9 o'clock, ladies and gentlemen. 10, 11, 12. Got 3 hours to go. And we're actually making some good progress. So I'm pretty happy so far. Oh, you're back. You're back. The dogs are freaking out because the neighbors got a whole bunch of fireworks that they're playing with. And the dogs don't like that, so they're trying to lay down underneath the desk where my legs are, and also the space heater is there. Go lay down. Go lay down. Baka, 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 baka. Nobody's watching 'cause no one cares. The dogs care. The dogs always care. Blessed be the dog. We're going to do the radiator now, which is going to be 14 wide, 18.5 tall. Yeah, so 14. 14.6 tab 18 point. Oh, what the One person's viewing right now. What are you up to? How's it going? Just trying to get these radiators in. If you have any questions or curiosities, don't hesitate to ask. And he's gone. Damn it. And it crashed. Let's get it fired back up. Hi. Hi, Ranger. Hey, there's one person. Happy you could join us. Happy New Year. Where are you at in the world? Ask questions, say things, don't say things you don't have to if you don't want to. Got any car projects you're working on? Race car stuff? What should I work on now? Got a whole bunch of stuff that's just a looming problem. Let's see. Let's see. What are we going to do here? I don't like how this windshield here is lining up at all. Hmm. Lay down. Lay down, Ranger. Lay down. Lay down. Oh. I'm just thinking, what am I going to do?